First off, thanks everyone for coming to take the time to chat with us here today. See there's folks from all over joining, and I think I'm really excited about that. So this is our bi-weekly Tuesday webinar, where we like to go really deep into a topic in core Airflow. A couple of logistical notes before I hand it off to Mark to get started. First off, the recording, as well as all of the sample code and so on, will be sent to you afterwards. Look for an email in your inbox. And if you have any questions that come up as Mark's going through the content, please feel free to drop it in the chat or the QA section, and we'll definitely get to it as soon as we can. That being said, would like to introduce a man that needs no introduction within the Airflow community, the great Mark Lamberti. So Mark, I will kick it over to you.
Thank you, Viraj. So hi everybody, my name is Mark Lamberti. I'm the head of customer training at Astronomer, and I'm super excited to have you here because, well, in maybe the next 60 minutes or less, you are going to discover everything you need about sensors to create better, more reliable, and powerful data pipelines. So I hope you're ready for it. So first, you will see what exactly is a sensor. And I'm pretty sure that you already know what is a sensor, but it's always good to have a quick reminder. Then what are the best practices around sensors? And last but not least, why this is important for you. But as usual, I would like to start from use cases, because I truly believe that it's always good to know why you need something based on use cases. So let's see exactly some use cases that you can solve with sensors. So let's imagine that you have the following data pipelines. And basically you have different data pipelines because the way you extract data from your different partners is different. So you might have one DAG in charge of extracting data from partner A, then another DAG in charge of extracting data from partner B. But the way you store those data is common to all of your partners. So in that case, you would like to have one DAG in charge of storing your data for all of your partners, and you would like to have those beautiful tasks in charge of waiting for the other DAGs. And this is something that you can solve with sensors. Another use case might be the following one, and this one is really common. Let's say that you are waiting for files to land at a specific locations, but you don't know exactly when those files will arrive. Or even like you might have different locations. So again, how can you solve this? Well, this is where sensors are truly useful. With sensors, you're able to say, okay, I want to wait for file A that will exist in that location, then another file B in another location, and so on. So again, if you are waiting for some files, sensors are truly useful for that. Then last but not least, I love this use case. Let's say that you have a DAG that it is triggered daily, every day. But for some reasons, you want to execute one task at 10 p.m. And then you want to execute another task at 2 p.m. How can you do that? How can you have those kind of multiple schedule intervals within the same DAG? Well, again, this is solved by using sensors. So as you can see, based on those really common use cases, sensors are truly powerful. But before jumping into the code and what exactly is a sensor, let me give you the quick agenda of today. So first, what is a sensor? Again, quick reminder of it. It's always good for our memory, especially mine. Then make your sensors better. How can you make your sensors better in order to create more reliable, complex, and powerful data pipelines? There are some best practices that you need to know around sensors. Also, how can you create DAG dependencies with the external task sensor? The external task sensor is truly powerful, truly useful, but you have to know exactly what are the best practices around this sensor. Otherwise, you might end up with weird behaviors. Then last but not least, the smart sensors. Big topic here. Does that mean that the sensors we use daily are stupid? Well, we will answer that question at the end of the webinar. So without further ado, let's begin with what exactly is a sensor. So a sensor is a kind of operator waiting for something to happen before moving to the next task. So for example, you are waiting for a file, you can use a sensor. you're waiting for a SQL entry, you can use a sensor. Basically, a sensor will check if a condition is true. If your condition is true, then the next task will be executed. Otherwise, it will wait according to the interval of time that you have defined and checks your condition again. It is as simple as that. A sensor checks a condition at a given interval of time. Right? This is a sensor. Now, there are a ton of different sensors that you can use. And most of the time you always hear about the file sensor, but it is definitely not the only sensor that you can use. For example, you have the datetime sensor. You want to execute a task at 10 p.m., then another task at 2 p.m. within the same DAG. This is the goal of the datetime sensor. Or maybe you want to create DAG dependencies between your DAGs. You want to wait for a task to get completed in another DAG. Well, in that case, the ExternalTaskSensor is the way to go. Or you might have an API and you want to make sure that your API is available. Well, that's the goal of the HTTP sensor. Also, the SQL sensor. What if you want to wait for an entry in your SQL table? The SQL sensor will help you for that. Or maybe you have a very complex condition that you want to evaluate. And in that case, the Python sensor will help you a lot. With the Python sensor, you can just execute a Python function, do whatever you want within that Python function, and this is your condition. Then last but not least, the subDAG operator. The subDAG operator is a sensor. Okay? That wasn't the case before, but now it is a sensor. So for example, if you want to, let's say, the goal of the subDAG operator is to wait for tasks to get executed within your subDAG, well, in that case, you can leverage the arguments of a sensor has, okay, to avoid deadlocks. So keep in mind that there is really a ton of sensors that you can use. Just to give you a little bit more information about sensors, a sensor inherits from the base sensor operator, which has a lot of different arguments that you can use, and we are going to see that later, just after that slide. And the base sensor operator inherits from the base operator. So with the base operator, so your sensor has a lot of arguments corresponding to your sensors and your operators. Okay. All right. So that being said, let's implement our first sensor and see the best practices around that. So first, let's imagine that you have the following data pipeline. Okay, so this data pipeline is in charge of processing partner data. Now, you have this table, partners, which has the following columns: names, execution date, description, and processed. So basically, you might have a DAG in charge of processing partner data, and you want to say, okay, as soon as the data of my partner is processed, then I want to get an entry in my SQL table, partners. And so the processed field will be set to true. Okay, that's what you can see here. As soon as this entry exists in the SQL table, then I want to move forward. I want to execute the storing task, for example. Well, in that case, in order to solve this, you will need to use the SQL sensor. So let's see how to use it. First, if you want to get some information about the SQL sensor, I strongly advise you to take a look at the astronomer registry. The astronomer registry is really the best place to go if you want to find information about any operator. So for example, here, let's type SQL sensor, and then you select it, and that's it. Okay, you get information about your sensor, then the different parameters, what are the parameters that are required, and also how to install it and how to import it within your DAG. It's really a convenient way to get information about your operators and how to install and import them. So that being said, let's copy this import. Okay, and as you can see, the SQL sensor exists by default. You don't have to install any provider for it. And let's go back to the code. So first, you import your SQL sensor. And as you can see, I'm using the Task4 API. If you want to learn more about it, take a look at the Astronomer Academy. And let's implement the first task. So here, we are going to create a task waiting for partner equals to the SQL sensor. And in that case, you need to specify your task ID as usual. So let's say waiting for sensor, for partner, sorry. And then a connection ID, right? Because the SQL sensor interacts with Postgres. So let's type con ID equals to Postgres. Obviously, you will need to create the corresponding connection. And then this is really specific to the SQL sensor. You need to specify the SQL request that is in charge of getting the record and checking if the record is what you expect or not. So here you type SQL equals to SQL slash check underscore partner dot SQL. And actually, this is really a best practice, right? If you, whenever you use a SQL request within your operator, this is not related to sensors, but try to keep your SQL requests outside from your DAG files. Okay, and if you take a look at checkPartner.SQL, you have the following SQL request that basically select the processed column from partners based on a name, the partner name, and the execution date, which is here templated, as you don't want to get the same chunk of data again and again. Now, once you have this, you need to specify the parameters that are used in your SQL request. So parameters equals to a dictionary. And in that case, you have name equals to partner underscore A. Okay, and keep in mind that this argument is not templated, which means you're not able to inject data at runtime within that argument. Okay, usually we forget about this. Once you have your parameters, you can specify success, which expects a function that indicates the criteria to say, hey, actually, this record is what I expect. So the sensor should succeed. In that case, we're going to use underscore success criteria. Okay, so here basically we just say, okay, if we have a record, we return it, and that means the sensor will succeed. Otherwise, we need to specify failure, which again expects a function, and that corresponds to the failure criteria. Okay, so here we say, if the record doesn't exist, then the sensor should fail. Okay. Another argument that you can use with the SQL sensor is fail underscore all underscore empty set to true. If you set this argument to true, that means if your record that you get from the SQL request here is empty, then you want to put your sensor in failure. Okay, you can do that by using fail on empty. Okay, so this is really specific to the SQL sensor. Now, what about the best practices around sensors? Well, the first parameter that you have to take care of is poke underscore interval. And poke underscore interval by default is set to 30 seconds. As a best practice, you should define a meaningful value here. The poke interval argument defines the interval of time at which your DAG will check if your condition is true. So by default, it will check every 30 seconds, if you every 60 seconds, sorry, if your condition is true or not. Try to define a meaningful value here. What I mean by that is, if you expect that, I don't know, your condition will be true within 30 minutes, then it might not be good to define a poke interval to 30 seconds, right? Because you are going to make a lot of requests, a lot of checks for nothing. And this is especially true if you are interacting with an API or database. You don't want to send a lot of requests to your API or to your database. But at the same time, you don't want to use a very long interval of time because, well, it will take longer for your sensor to complete in that case. So there is this kind of trade-off between if you set a short poke interval, then your sensor will get completed as soon as the condition is true. But at the same time, if you do that, well, you might use a lot of resources for nothing. Okay, so here, let's say 20 seconds in that case. Then, this one is pretty important, the mode. By default, it is set to poke. Okay, what does it mean? Whenever a task runs in Airflow, that task takes a worker slot within a pool. And that pool has a limited of worker slots, has a limited number of worker slots. By default, it is 128, I think. But the thing is, well, whenever a sensor runs, it takes a worker slot until it gets completed. But your sensor can run like for, I don't know, 2 days, 3 days, 4 days. So it will take, during 4 days, a worker slot. And this is why, if you don't define the right mode, you can end up with a deadlock. And so you are, for instance, will get stuck. You won't be able to execute any more tasks in your entire Airflow instance. Pretty dramatic, right? Let me tell you exactly what is a deadlock. So let's imagine that you have the following pool with only 4 slots, okay? And in that pool, you have one sensor running. So now you have only 3 worker slots available. Then you might have a second sensor running. So now you have 2 left, 2 worker slots left. Maybe a third one, only 1 left. And maybe a last sensor. So now you have 0 worker slots available, which means if you have another task that you want to execute, task A, you won't be able to execute that task. Why? Because all of the worker slots are taken by your sensors. So you will need to wait for one of the sensors to get released, to complete, in order to execute task A. Otherwise, right now, you are in a deadlock. You are not able to execute any more tasks in your entire Airflow instance. And it's really easy to end up with a behavior like that. So that's where you can use the mode Reschedule. So by defining the mode with Reschedule, you are saying that, okay, instead of keeping the worker slot until my sensor gets completed, I want to release the worker slot during the interval of time I'm waiting. So for example, here you are going to say, during 20 seconds, does nothing, don't take a worker slot. Other tasks will be able to take worker slots, but 20 seconds later, I want to take a worker slot again in order to check the condition. Basically, you will take a worker slot only for checking if your condition is true, not for waiting the interval of time. So by default, if you expect that, for example, your sensor will take more than, let's say 5 minutes or 10 minutes, it might be interesting to set the mode to Reschedule. Keep in mind one thing. Whenever you use the Reschedule mode, you are putting like a little bit of overload onto your scheduler, because the scheduler will be in charge of saying, okay, this sensor doesn't take a worker slot anymore, so let's release the worker slot. Let's check if there are other tasks to execute. And as soon as the interval of time is elapsed, then this sensor takes a worker slot again. And this will be the job of the scheduler to do that. So that's why with the Reschedule mode, you are putting a little bit of work in addition to the scheduler. And as a best practice, if you have a very short poke interval, don't set the Reschedule mode for your sensor. Because if you have a lot of sensors, you might end up with troubles, or you might put a lot of workload onto your scheduler. Okay? Now, the other argument is timeout. Oh my gosh, this one is truly important. By default, it is set to 7 days, which means if your condition is not true, your sensor will wait 7 days before timing out and failing. It's huge. And because of that, you can end up with a deadlock. Because let's imagine that your DAG is, triggered daily. And you have like a sensor that should be completed within 10 minutes, but you didn't define the timeout. So it will keep running during 7 days before failing. That's huge. So as a best practice, you should always, always, always define a timeout, a meaningful timeout. If you expect that your sensor will get completed within 10 minutes, then it doesn't make sense to have a timeout set to 7 days. Set it to 12 minutes, for example. Okay. So in that case, you can say, okay, I want to say this sensor should get completed within 5 minutes. And now there is a question that I got so often. What is the difference between timeout and execution _ timeout? Because execution timeout is available for any operator, right? So what is the difference between those two parameters? Well, you have to know that timeout works with another argument called soft _ fail. And when this argument is set to true, that means instead of putting your sensor in failure when it times out, you are going to put it with the status skipped. Okay? And this argument is taken into account only if you use timeout, not with execution timeout. That's the difference between timeout and execution timeout. Then the last argument, pretty useful, is exponential _ backoff. And when you set this parameter to true, you are going to wait longer and longer at each interval of time of your sensor, which is truly useful if you interact with an API or a SQL database. You don't want to overload your resources. With the exponential backoff, you can do this basically. You can say, okay, if it doesn't work right now, I'm going to wait the interval of time. Then if it doesn't work after that interval of time, I'm going to wait longer and longer and so on. So it's really like a smart way to retry your sensor. That's what you need to know about sensors. Basically, if there is something that you need to remember here, is that you should always define a timeout, always. Okay, because by default it is set to 7 days, and you might end up with a deadlock if you keep it, or basically you're going to waste resources. And the mode. Define the correct mode, either poke or reschedule. Poke if you expect that your sensor will take maybe, I don't know, 2 minutes, 1 minute to get completed. Otherwise, use the mode reschedule. And exponential backoff, pretty useful if you interact with an API or a SQL database. Okay? So that's all you need to know about sensors. That's really the best practices around sensors. Now, if you save the file, and let's go back to Airflow instance, Airflow UI. Let's close the page. So looks like we have a quick issue here. I guess it's parameters and not, okay. So now, well, that's the beauty of live coding, right? So I just made some typos. Here we go. Okay, so if you execute the DAG, partner, let's refresh the page. Okay, let's go back to partner. As you can see, it works. Well, basically because the SQL entry already exists. But if you go to admin and XComs, you can see some XComs here, right? And those XComs are not automatically removed. You have to take care of your XComs. And one thing you might want to do is to have like one DAG in charge of cleaning those XComs. And to say, okay, as soon as the last task of partner, so storing, is completed, then I want to run that DAG. I want to run that DAG in charge of cleaning the XCOMs, and I want to clean the XCOMs corresponding to the DAG partner. And that's exactly what you are going to do with the external tasks sensor. So let's do this. In order to do that, there is this DAG, cleaning_DAG, which basically does nothing else than cleaning your XCOMs, as shown right there with the Postgres operator. And it executes the following SQL request in charge of cleaning your XCOMs corresponding to the DAG ID partner. Now, let's implement the external task sensor. So, first thing first, you need to make the following import. And as you can see, you don't need to install any provider for it. Okay, it is brought by default. And the goal of the external task sensor is to wait for a task in another DAG to complete before moving to the next task. So let's implement that beautiful operator. So we create a new task, waiting for partner, equals to the external task sensor. And then obviously you need to define a task ID. So in that case, we can say waiting for partner. Then you need to define the DAG ID, the DAG ID of the DAG where the task you are waiting for is. So in that case, external DAG ID equals to partner. Okay, that's what you have. That's what you have right there. Then you need to specify the task ID of the task you are waiting for. So again, external_task_ID. It's pretty straightforward so far. So let's put the task ID storing. Okay, that's exactly what you have right there. This is the task ID. And again, if you're wondering what this notation is, well, this is a task API. It's really the new way of defining your DAGs. I love this notation. If you want to learn more about it, please let me know. So once you have your external DAG ID and task ID set, well, you're basically done, right? I mean, there is no much work to do for the external task sensor. But here's the thing. You have to keep in mind that the external task sensor expects that the execution dates between the DAG where the sensor is running and the DAG where the task you are waiting for are equal. If they are not equal, then your external task sensor will keep running until it times out. And there is an issue here because the schedule interval is defined to 10 a.m. So that means this DAG will be triggered every day at 10 a.m. Whereas the other DAG partner, where the task you are waiting for is, well, the schedule interval is set to daily, which means it gets triggered every day at midnight. So there is this delta of 10 hours. How can you fix this? Well, the external task sensor gives you two ways for doing that. And the first way and the easiest way is actually by using the execution_delta argument, which expects a time delta object. So in that case, as the delta is 10 hours, you can put hours equals to 10. One thing to keep in mind is if you want to go backward, then you need to specify a positive value. Okay, so here I'm actually saying that I want to get aligned with the execution date of partner, so at midnight. Okay, the DAG is triggered at 10 a.m. So 10 hours before you end up at midnight. Okay, so that's really the easiest way of like aligning your execution dates between your DAGs. Now there is another way that you can use, which is execution_date_fn, which this time expects a function. And that function, for example, could be, let's say, get execution dates. And this function should return execution dates. So for example, you implement the function that gets only one argument, which is current execution date. And then you can say, okay, I want to return a list, as you can return multiple execution dates from that function. And you want to say the current execution date minus time delta hours equals to 10, which is basically equals to what you have done with the execution delta argument. But the point is, if you have like a more complex way to, if you need a more complex way to define the delta between the execution date of the DAG where the sensor is running and the execution date of the DAG where the task you are waiting for is, you can use execution date fn for that. Okay, because you can return multiple execution dates and you can do pretty much whatever you want within that function. Now, keep in mind that you are not able to use both at the same time, which actually, I mean, it doesn't make sense to have the execution delta as well as the execution date fn defined. So use one or the other. In that case, let's keep execution delta here. Now, let's save the file and, well, let's see if it works. So let's go back to the Airflow UI, go back on DAGs, and let's trigger cleaning underscore DAG. Remember that right now with XComs, we have those XComs. So turn on the toggle of the DAG, and let's refresh the page. Okay, and as you can see, it's already done. If you click on your DAG and go to graph view, well, here the dependencies are not correctly defined, but should have uncommented those lines. But if you click on waiting for partner and go to logs, you can see that the external task sensor is poking on the task storing within the DAG partner on the following execution date. And this execution date is exactly the execution date that you have for partner. That's what you can see here. Okay. So that's how it works. Now, there is something else that you truly need to know about the external task sensor. Let's imagine that, well, actually the task storing didn't succeed. So let's click on it and mark it as failed. Okay, so now, as you can see, the task storing is in failure. If you go back to DAGs and clean underscore DAG, then retry your external task sensor by cleaning it. Okay. Well, your sensor will keep running forever. I mean, until it times out. Why? Because there is one argument that you always have to define, which is failed underscore states. And by default, this argument is set to none. So, which means if you don't define the execution, the failed states argument, then again, your external task sensor won't be able to say, hey, actually the task you are waiting for has failed, so I should fail as well. That's why always define this argument. Failed underscore states equals to a list of states. And in that case, let's say you want to say, okay, if the task is skipped or is failed, then I want to put the external task sensor in failure as well. This is truly important to do that. Otherwise, again, you can end up with a deadlock. And by default, this argument has no value. Another argument, which is actually the opposite of that one, is success underscore states. But by default, it is set to a list of states with success in it. And I'm pretty sure that this is exactly what you're looking for, right? But fail underscore states, you have to define this one. Otherwise, it won't work. Now, the last argument that it is pretty new for the external task sensor is check underscore existence. And by default, it is set to false. I strongly advise you to set it to true. Why? Because, well, by default, your sensor, the external task sensor, won't check if the task ID or the DAG ID exists. So instead of waiting for your sensor to time out or getting an error, you can just use check underscore existence and set this argument to true. And if the partner, the DAG ID or the task ID don't exist, then your sensor will fail right away. Okay, so this is really a best practice as well around the external task sensor. All right. That's the most important arguments that you need to specify with the external task sensor. One thing to, just in addition, just a little bit of information here. For the coming version, I'm not sure yet when this will be released, but I saw that there will be another parameter, another argument for the external task sensor that will be external task IDs. Okay, so you will still have external task ID, but you will have another argument called external task IDs, which expects a list of task IDs, and so you will be able to wait multiple tasks at the same time. Okay, it's not yet available, but I just wanted to give you a little bit of teasing here. Okay. All right, so let's go back to the DAGs. Let's set the task to success, like before. And now let's run the sensor again. So let's clear it. At some point should get, oh, I just got an error. Oh yeah, okay. So let's run it again. And now it's done. All right, and actually, if you take a look at the XComs, well, that's because let's run the DAG again. Okay, so let's clear it. All right, let's wait. And now if we go back to XComs, well, that's the live demo, right? But the XComs should disappear. Okay. So that being said, well, actually, I know why. That's because the execution date is not the correct execution date in the SQL request here to clean your XComs. But you get the idea. Now it's time to move to the last point of the webinar. Well, in Airflow 2.0, there is a new concept that has been introduced, which is the concept of smart sensors. So does that mean that the external task sensor here is actually stupid? Well, not really, but sensors have some drawbacks that you have to be aware of. And the first drawback of sensors is that, well, you will underutilize your resources a lot. Because most of the time, your sensors do nothing, right? They are just waiting for a condition to be true before moving forward. So if you have a lot of sensors running at the same time, most of the time, they will do nothing, but they will keep using your resources and they will keep using worker slots. So that can be a real big issue at some point. Again, if you have a lot of sensors, this is definitely not something that you want. You want to optimize your resources. Maybe you pay for your resources and, well, you don't want to wait for nothing. So that's the first drawback of sensors. The second one is each time a task is running within Airflow, that task emits heartbeats. Okay, to say, hey, actually, I'm still alive, so don't kill me. Well, if you have a lot of sensors running, again, you will have a lot of heartbeats sent to your scheduler. And at some point, it may put a lot of pressure to your scheduler. Okay, because you will make a lot of requests to your scheduler for your heartbeats. So that's the second drawbacks of sensors. And the last, and maybe one of the most important one, is that you might end up with duplicates. Because here's the thing. You definitely might have one sensor in one DAG waiting for something and another sensor in another DAG waiting for the exact same thing. And you have a duplicate. Okay, that would be nice to have a way to say, okay, if those two sensors are waiting for the same thing, then I don't want to have duplicates. I just want to run one sensor, and if that sensor succeeds, then that means the other sensor should succeed as well. So because of those three drawbacks, and the fact that each time you implement a sensor, you have to ask yourself a lot of questions like, well, should I really need a sensor? Did I configure well the parameters to avoid, getting my Airflow instance stuck? Or how long does it take for this sensor to get completed, and so on. So all of those things, well, that's why the smart sensors have been introduced. Basically, the idea behind the smart sensors is to say, well, instead of having one process for one sensor, I want to have centralized processes and execute the sensors in batches within those processes. That's the idea behind smart sensors. Now, how does it work exactly? Well, first, sensors work in two different steps. The first step is to register, is to serialize basically your sensors within the database. So let's imagine that you have some smart sensors here. Those smart sensors will get serialized by using JSON within your database. And then you will have a smart sensor group shard, which is nothing more than a real DAG. Okay, so a smart sensor group shard is a DAG, a real DAG with a start date, a schedule interval, and so on, that will be in charge of instantiating a smart sensor operator where the different smart sensors will be triggered in batches. Okay, in batch. That's how it works in the very high point of view. Two steps: your smart sensors get serialized in your database by using JSON, and then a smart sensor group shard, which is nothing more than a DAG, will be in charge of triggering your sensors at a given interval of time, which is 5 minutes by default. Okay, and this is done in batches. Now, that being said, it's not that simple. It's not simple at all in order to use smart sensors. That's why, first, this feature is still in beta version, right? And it is a feature that it is not so commonly used across many people, across many companies. But let me give you an example of how can you implement a smart sensor, and actually how can you make the external task sensor smarter. So let's go back to our data pipeline for that. And as there is a lot of work to put, I've already done that, but let me explain you the code. So first, whenever you need to use a smart sensor, there is some configuration settings to enable. And to do that, as I'm using the Astronomer CLI, and you should do that if you want to try Airflow and make your own experiments and so on, I've exported some environment variables. And the first one is use smart sensor. You have to specify this argument, this configuration setting to true in order to say, hey, I'm going to use smart sensors within my DAG. Then there is the shard code upper limit. So basically, each time a smart sensor gets serialized, that smart sensor will have, how can I say that, a hash code corresponding to your sensor, to that sensor, okay? And this hash code is defined according to the shard code upper limit and the POC context. So the context of your sensor. Okay, you don't have to, you don't have to dive into the details here, but basically this argument allows you to define how your sensors will be spread amongst all of the smart sensor executors or the smart sensors shards. Okay, so basically with the other argument, sensor shards, you are saying that you want to have, in that case, one smart group, I don't remember exactly the name, one smart sensor group shard. So one DAG in charge of processing your smart sensors. Okay, you can define this argument to 5 if you want to have more smart sensor executors, but basically that's how it works. So again, each time a smart sensor is serialized, that smart sensor will get a hash code, and that hash code will be used in order to spread your sensors among the different smart sensor executors. And the number of smart sensors executors that you have is defined with sensor shards. Then last but not least, you will need to create a custom operator, a custom class actually, to say that this sensor should be a smart sensor, and you need to put that class, your custom class, within the argument sensors enabled. Okay, so in that case, smart external task sensor. Now, in order to make the external task sensor smarter, you need to create a new file within the folder plugins. And in that case, I've created the following one, smart external task sensor, which inherits from the external task sensor. Once you have done that, there are two things that you absolutely need to specify. It is required. The first one is the poke context fields, which defines, well, basically, which specifies the arguments needed by your sensor in order to instantiate your sensor, in order to instantiate it. So in that case, external DAG ID, external task ID, execution date FN, fail states, and so on. Now, I don't want to confuse you, but this argument is used as well in order to share context information between your sensor and your smart sensor and your DAG. What I mean by that is, keep in mind that the smart sensor here won't be executed within the DAG where it is called. So in that case, smart cleaning DAG, but it will be executed within the smart sensor executor. Okay, within another DAG. And so you won't have access to the execution date, the DAG object, the DAG run, and so on. Okay, you won't have access to those information by default, because the way they are called in the smart executor, in the smart sensor executors, well, you don't have access to those information by default. Okay, that might be really confusing, but that's how it works. So keep in mind here, by default, you need to specify the arguments that you're going to need in order to initialize your smart sensor. So in that case, external DAG ID, task ID, and so on. Then the second thing that you need to do is to override the method is smart sensor compatible. In order to say that this operator, this sensor is a smart sensor, you have to make sure that you are not using soft fail, neither any callbacks. So whenever you use a smart sensor, you are not able to use soft fail and on failure callback, on success callback, and on retry callback. Okay, if you use one of those callbacks, your sensor, your smart sensor won't work. And that's the goal of this method, to say, okay, I'm not using soft fail, neither the other callbacks. Okay, that's what you are doing here. And again, why? Well, because that's the way it works with smart sensors and the way they are called within the smart sensor executors. Now, as I'm using the external task sensor, I have to admit it was really painful to make the external task sensor smarter. Why? Because, well, first, if you put the smart external task sensor, so this class, within the DAG where you want to use it, you will end up with a weird serialization error. But also, as within the external task sensor, the execution date is fetched from the context, okay, of your DAG, which again you don't have access to by default when you use a smart sensor. Well, you will end up with an error as well, saying that, well, the execution date doesn't exist in the context dictionary, because actually your context dictionary corresponds to the poke context fields here. I mean, it's really a nightmare. Okay, it's really a nightmare. So that's why I had to do a lot of work here in order to first pass an execution date like that. Okay, so this doesn't exist by default. I added this execution date. That's what you can see here as an argument, execution date, which expects a templated argument, in that case, the execution date. Okay, that's what you can see here. And also, I'm leveraging the execution date fn, and I don't specify a function here. I just specify true for that argument, because if you go back to the custom class here, I'm overwriting the following function. And this function internally in the ExternalTaskSensor returns the execution date. Okay, so I had to modify this function in order to return the right execution date and get the ExternalTaskSensor working with works with the smart sensors. Okay, I know it's a lot. It's really a lot. But my point is, if you get, you will get this code after the webinar, so you will be able to have this smart ExternalTaskSensor. But I don't recommend to use it, right? Because it's really hacky. Maybe there is a better way to do that. I didn't find it. But my point is, smart sensors solve like all the drawbacks that sensors have, but in my opinion, I don't recommend to use them because not so many people use smart sensors, and actually they are really useful if you have a ton of sensors. Okay, keep in mind that this new feature has been introduced by Airbnb, which obviously has a lot of sensors to deal with. But, well, now you know how it works, you know what are the requirements. You need to define a class, you need to define poke context fields, you need to define this method. It might be easier if you use the file sensor, for example. If you want to make it smarter, it will be easier than with the ExternalTaskSensor. And you need to configure your F instance with the following values. Okay, and then you will be able to execute your smart sensor. And to do that, as you have the smart sensor executor here corresponding to a DAG, again, you have to turn it on, and then you can turn it on your smart sensor here. Okay, so if you refresh the page, you can see that the smart sensor executor is running, and so it will check at a given period of time every 5 minutes by default to see if your smart sensors can get executed or not. Okay, and you can see that right now this sensor doesn't have the status running, but the status sensing, which means it is a smart sensor. If you take a look at the logs, you can see that the task has been successfully registered as a smart sensor. Okay. Whew, I know it's a lot. I know it's a lot. Don't hesitate to watch the recording again, but that's how smart sensors work. They're really painful to use. They solve a lot of drawbacks, but I don't recommend them because, well, they're really hard to use. They are really hard to implement. And there is a new feature that it is coming pretty soon, which I think is deferrable operators, and they will solve pretty much the same issues, the same drawbacks, but in a much easier way. Thank you, everyone. It was a great pleasure. I know it's a lot of information, but again, the recording will be available after the webinar. You will get the code as well. And now it's time for answering your questions. Thank you, everybody. It was a pleasure.
Mark, that was amazing. Thank you so much for all that wonderful detail. And there's a bunch of questions that have piled up in the chat. I tried answering some of them, but I think for some of them, you know, need your expertise. Kind of go here. Dinesh is asking, how do you diagnose a deadlock situation?
How to diagnose a deadlock situation?
Yeah.
Well, actually, the only way to diagnose this is if you don't get any more tasks getting triggered in your Airflow instance. So I think there is maybe Viraj, you can tell me this, but I think there is a metric that you can use if you monitor your Airflow instance to check the number of task instances right now that are getting triggered in your pools. But otherwise, basically, you will just see that you are not able to execute any more tasks in your Airflow instance. Okay, that's the way to see that you are basically stuck.
Exactly. Yeah, that might show up in your schedule logs. I think there's a few Airflow metrics that actually have that data too. Biggest thing is you'll see that none of your tasks are running.
Yeah.
Cool. John is asking if there's a way to limit poking to a time window. So, if the file is dropped on the FTP between 4 and 5, I don't want to poke outside of 4 and 5. How would I limit that?
Well, I think it's really the role of the timeout. Your sensor will get triggered. As soon as your DAG is triggered, right? And so, for example, if it runs daily, then you might set your poke interval to, I don't know, 5 minutes and say, okay, my sensor should get completed within 30 minutes. So if it takes more than 30 minutes to get completed, then I just want to time out. Okay, I just want to stop my sensor. So I think the way to do that is by leveraging the timeout. I don't see another way to do that.
Yeah, I think that'd be the best way to do it. Thank you for that, Mark. Here we go. Another question is the ExternalTaskSensor, do you have to set up a separate service to use that, or do you use that right out of the box?
Oh, it's right out of the box. Like the ExternalTaskSensor is, you don't have to install any provider to use it. As soon as you install Airflow, you will get it and you will be able to use it within your DAGs.
That's awesome. Works right. So, question from Adam Spain. For the first example you showed, right, the success criteria, what's being passed in the function as record? Is it the result of the query?
Yeah, exactly. With the SQL sensor right there, you will get basically the record here. So it's the result of your query. Okay, so by default, the SQL sensor will return the first column of your the SQL request of your SQL request. Okay.
Yeah, that's nifty, right? You don't even have to do that result already stored for you.
Correct.
Question from Eduardo: is the sensor timeout argument valid only to the time of a single sensor request, or sum of all timings of all the requests made by a sensor?
I guess I'm not sure if I understand well the question, but I guess the answer is the sensor timeout argument is valid only for a single sensor and not for all of your sensors at the same time. So you have to specify the same argument again and again. But one thing you can do is to create a custom operator, a custom sensor, and define those arguments by default, and then use that custom operator as your sensor with the default arguments, with the default timeout and so on.
And last question before we go here is, can sensors share other sensors?
So, sorry, I didn't hear you again.
Oh, sorry about that. A last question from Melio is, can you use sensors to wait and trigger other sensors?
Well, I think I just lost you again. So it's my connection. Sorry for that. But if you can answer the question, don't hesitate. But I can't hear. I didn't hear you.
Oh, it might be my internet. Melio, I believe you can use sensors and wait for other sensors. Thanks for asking.
Oh yeah. Yeah, you can definitely do that. You can definitely do that. Is it something that we recommend? I don't think so. It can be really tricky at some point. Try to keep things simple and just have one sensor and one sensor at a time.
Alrighty, everyone.
All right. Thank you, everybody. Thank you very much. It was a pleasure. It was a pleasure to have you. And again, you will get the recording, and you will get the code, and you will get this beautiful, incredible, smart external task sensor. So see you soon for our next webinar. Oh, and by the way, just one thing, Viraj, just before. Here is the code for the certification, for the new certification. You can get a huge discount by using it. So don't hesitate to use the early bird coupon. That was our gift for you. Have a great day, everyone, and see you soon.
Thanks for coming.
Bye-bye.